Okay, so graphing exponential functions. When we have an equation like f of x equals a to the exponent of x, there's an exponent on that equation, so we can call it an exponential function. And for our first example, our a value is going to be greater than 0. It's going to be 2. So we're going to graph this exponential equation, and the easiest way to graph that for now is by using a table of values. And once we have that table of values and we graph that function and the next function, we're going to look at some similarities and key points that we can use to graph exponential functions more easily in the future. So for now, we have f of x equals 2 to the exponent of x. And we're going to create a table of values. So we're going to have our x and we're going to have our y. So when x, let's start off with something easy. When x is 1, what is y? So when x has an exponent of 1, that's 2 to the exponent of 1, and that's just 2. So when x is 1, y is 2. When x is 2, so that's 2 to the exponent of 2, y is going to be 4, okay? What about if we had 0? When x is 0, what is y? We know that anything to the exponent of 0 is going to be 1. So when x is 0, 2 to the exponent of 0 is just going to be 1. Okay, what if I add in some negative numbers into that? What if I say -1? When x is -1, what is y going to be? Well, the first thing we should know is that that negative, the only thing that it does is flip whatever we have. It reciprocates it. So if I have 2 to the exponent of -1, all that -1 is going to do is flip that 2 into 1/2. So it reciprocated it. So now it's 1/2. But what if I had -2? If I had -2, the first thing I would do is reciprocate it, so it'd be 1/2, and then I'd square the 1/2 to get 1/4. Because 1/2 squared is 1/4. 2 times 2 is 4, 1 times 1 is 1. Okay, so now I have all these points. So now I'm going to go to my graph and graph this function. Okay, so I'm going to make this on a scale of 5. So it's going to be 5, 5, -5, -5. Okay, so my first point is at 1 and 2. So 1 and at 2. My next point is at 2 and 4. So 2 and 1, 2, 3, 4. My next point is at 0 and 1. So 0 and 1. My next point is at a -1 and a positive 1/2. And my next point is at -2 and a quarter. So I notice something happening here. My function is getting close to that x-axis, but it's not reaching the x-axis. It's not passing the x-axis. It's just getting very, very close each time. So that means I have a horizontal asymptote when y is equal to 0. Okay, so if I have an asymptote, I have to indicate that, and I'm going to indicate that with a dotted line. And then I'm just going to connect these dots. So my function is going to approach the x-axis, but it's never going to cross the x-axis. Okay, so I have that. One thing I'm going to mention is that when we look at this function right here, I'm going to write this in a proper order. So I would have, if I wrote it over here, I would start off with -1, -2, 0, 1, 2. I'm putting it in proper order. So -1 would be 1/2, -2 is 1/4, 0 is 1, 1 is 2, and 2 is 4. So if I look on this side, my x values are increasing. And if I look on this side, my y values are increasing. So when your x and y are both increasing, it's called an increasing function. So I'll write that down here. This is an increasing function. Okay, so I have this graph now. And this is when a was greater than 0, because I had 2 in this case as my a value. But down here, I'm going to graph this function now. And this function has an a value of 1/2. So we're going to see how these two graphs are different. Okay. So for this graph, I'm going to do the same thing. I'm going to create a table of values. So I'm going to have my x values and my y values. Okay, so in this case, my equation, I'm just going to flip this around. Okay, so in this equation, I have f of x equals 1/2, and this has to be in brackets, x. Okay, so when x is a -1, so when my x value is a -1, that just means whatever my a value is, it's just gonna flip. So when it's -1 and I have 1/2 and I flip it, I'm gonna get 2. Okay, then when I have 0, anything to the power of 0 is 1. And then when I have +1, anything to the exponent of 1 is just going to be itself. So 1/2. Okay, these are some easy points that I can just plot. And normally when you graph any function or graph in general, you only really need 2 points. And I've got 3 here. So now I'm just going to go ahead and graph this onto here. And I'm going to do the same thing and have a scale of 5. And if I remember from this graph, I have a horizontal asymptote at y equals 0. So I have a horizontal asymptote going this way. Okay, so now I'm just going to plot my points. I have -1 and 2, -1 and 1, 2, 0 and 1, 0 and 1, and a +1 and 1/2. And same thing, just connect the dots. So this is going to approach the x-axis, but never cross it. Okay, so now I have that. And now we're going to look at the table of values once again and determine whether or not this is an increasing function. So when I look here, as my x values increase, my y values decrease. I started off at 2, then I went to 1, then I went to 1/2. So my y values are decreasing and my x values are increasing. So this is called a decreasing function. So this one is a decreasing function. Okay. Now another thing I'm going to explain to you is how to graph these graphs with ease. Okay, so there's a couple rules that we can remember so we can graph these graphs quicker and save some time. And these rules are, number 1, the first thing we should know is that when we have an equation, f of x equals ax, that a value right there is called your base, and that is your exponent. These may be terms you're already familiar with. Okay, so the second rule. Okay, so when you have an exponent of 1, so when the exponent is equal to 1, your y value is equal to your base. Okay, because if this was a 2 right here, and I had an exponent of 1, my y value would just be 2, which is also just my base. So when my exponent is 1, my y value is going to be my base. Okay, if my exponent is equal to 0, my y value is going to be equal to 1, because anything to the power of 0 is going to be 1. Okay, and my last rule is that when my exponent is equal to -1, my y value is going to be the reciprocal of my base. So it's going to be 1 over my base, because I know that negative just flips whatever my a value is, and the 1 is just to the power of 1, so nothing is going to change. So if I can remember these 4 rules, I can graph any function super fast. Okay, so let's look at a few examples with these rules now. Okay, so if I had f of x is equal to 5 to the power of x, I know that anything to the exponent of 1 is just my base. So if x is 1, my y is my base, and my base is 5. Okay, when my x is 0, anything to the exponent of 0 is 1. So 1. When my x is negative 1, anything to the exponent of negative 1 is just the reciprocal of the base. So if my base is 5, the reciprocal of that is 1 over 5. Now you've got 3 points to plot your graph. And you also know that you have a horizontal asymptote at y equals 0. So that's right on that x-axis. Okay, so now let's look at this one. And this one I have a fraction. So I know that when I have an exponent of 1, my y value is just my base. So when I have an exponent of 1, my y value is just my base. When I have an exponent of 0, anything to the exponent of 0 is 1. When I have an exponent of negative 1, anything to the exponent of negative 1 is just reciprocated or flipped. So 2/3. I just flipped the 3 over 2 to 2 over 3. And now you have 3 points to graph this function, and you also know that you have a horizontal asymptote at y equals 0. And that's how you graph exponential functions super fast and save a lot of time, just with these 3 points and knowing your horizontal asymptote.